Hello students, how are you? Okay, let's start the chapter Motion in a Plane. First of all, I shall explain you about the scalars and vectors. What are scalars? The physical quantities which have only magnitude and no direction are called scalars. Example: mass, length, time, speed, work, power. All are scalars. Now the vectors. What are vectors? The physical quantities which have both magnitude and direction are called the vectors. For example, displacement, velocity, acceleration, force, momentum, all are vectors. Now the how many types of vectors are there? First is position vector. What is position vector? A vector which gives position of an object with reference to the origin of a coordinate system is called the position vector. Displacement vector. It is that vector which tells how much and in which direction an object has changed its position in a given interval of time. Displacement vector. What is displacement vector? It is that vector which tells how much and in which direction an object has changed its position in a given interval of time. Equal vectors. What are equal vectors? Two vectors are said to be equal if they have the same magnitude and direction. Negative vectors. The negative of a vector is defined as an other vector having the same magnitude but having opposite direction. Now, the modulus of a vector. The magnitude or length of a vector is called its modulus. Modulus of a vector A value. Unit vector. What is unit vector? A unit vector is a vector of unit magnitude drawn in the direction of a given vector. Co-initial vectors. The vectors which have the same initial point are called the co-initial vectors. Co-terminus vectors. The vectors which have the common terminal point are called the co-terminus vector. Now, the triangle law of vectors addition. If two vectors can be represented both in magnitude and direction by the two sides of a triangle taken in the same order, then their resultant is represented completely both in magnitude and direction by the third side of the triangle taken in the opposite order. Triangle law of vector addition. If two vectors can be represented both in magnitude and direction by the two sides of a triangle taken in the same order, then their resultant is represented completely both in magnitude and direction by the third side of a triangle taken in the opposite order. Parallelogram law of vector addition. If two vectors acting simultaneously at a point can be represented both in magnitude and direction by the two adjacent sides of a parallelogram, then their resultant is represented completely both in magnitude and direction by the diagonal of the parallelogram passing through the point. If theta is the angle between the vector p and q, then r makes angle beta with p and tan beta equal to q sin theta upon p plus q cos theta. Velocity vector. What is velocity vector? If a vector undergoes a displacement delta r in the time delta t, its average velocity is given by vector v equal to delta r upon delta t. Acceleration vector. If the velocity of an object changes from vector v to vector v dash in time delta t, then the average acceleration is given by vector a equal to delta v upon delta t. Now the equations of motion in vector form. First is v equal to v0 plus at. Second is vector r equal to vector r0 plus vector v0 into t plus half vector a t square. Third is v square minus v0 square equal to 2 vector a dot under bracket vector r minus vector r theta. Projectile motion. Now the projectile motion. Any body projected into space such that it moves under the effect of gravity alone is called a projectile. The path followed by a projectile is called its trajectory, which is always a parabola. A projectile executes two independent motions simultaneously. First is uniform horizontal motion and second is uniform accelerated downward motion. Projectile fired horizontally. Suppose a body is projected horizontally with velocity u from a height h above the ground level. Let it reaches the point xy after the time t. Then the position of the projectile after time t, x equal to ut and y equal to half gt square. Equation of trajectory will be y equal to g upon 2u square into x square. Velocity after time t, v equal to under root u square plus g square t square, and beta equal to tan inverse gt upon u. Time of flight t equal to under root 2h upon g. Horizontal range r equal to u into t, and it will be equal to u under root 2h upon g. Projectile fired at an angle theta with the horizontal. Suppose a projectile is fired with the velocity u at an angle theta with the horizontal. Let it reaches the point xy after the time t. Then the components of initial velocity ux equal to u cos theta and uy equal to u sin theta. Components of acceleration at any point ax equal to 0 and ay equal to minus g. Then the position after time t, x equal to u cos theta into t and y equal to u sin theta into t minus half gt square. Equation of trajectory. Y equal to x tan theta minus g upon 2u square cos square theta into x square. Maximum height h equal to u square sin square theta upon 2g. Time of flight t 2u sin theta upon g, and horizontal range r equal to u square sin 2 theta upon g. Maximum horizontal range is attained at theta equal to 45 degree and r maximum equal to u square upon g. Velocity after the time t, Vx equal to u cos theta and Vy equal to u sin theta minus gt. V equal to under root Vx square plus Vy square and tan beta equal to Vy upon Vx. The velocity with which the projectile reaches the horizontal plane through the point of projection is same as the velocity of projection. Uniform circular motion. When a body moves along a circular path with uniform speed, its motion is said to be uniform circular motion. Now the angular displacement. It is the angle swept out by the radius vector in a given interval of time. Theta radius equal to arc upon radius. Now angular velocity. The angle swept out by the radius vector per second is called the angular velocity, and it is denoted by omega. Omega equal to theta upon t. Time period and frequency. Time taken for one complete revolution is called the time period t. The number of revolutions completed per second is called the frequency. Omega equal to 2 pi upon t, and it will be equal to 2 pi nu. 1 upon t means nu. Nu is the frequency. Relation between nu and omega. Nu and omega. Nu equal to r omega. Linear velocity equal to radius into angular velocity. Omega is the angular velocity and nu is the linear velocity. Angular acceleration and its relation with linear acceleration. Angular acceleration and its relation with linear acceleration. The rate of change of angular velocity is called uh, angular acceleration, and it is given by alpha equal to omega 2 minus omega 1 upon t2 minus t1. A equal to r alpha, meaning that A means linear acceleration and alpha means angular acceleration. Then linear acceleration equal to radius into angular acceleration. Now the centripetal acceleration. A body moving along a circular path is acted upon by an acceleration directed towards the center along the radius. This acceleration is called centripetal acceleration, and it is given by A equal to V square upon R, and it will be equal to R omega square. I hope you have liked my video. If you have liked my video, please like and subscribe my channel. Thank you.